This conference will now be recorded.
Hello, everybody. Jordan Girth here with the National Weather Service Office of Observations. Thank you so much for joining us for the Satellite Book Club Seminar Series. This is session number 199, which means that next week will be the 200th Satellite Book Club. What an accomplishment. Thanks to all of you for joining us each and every week, or as you are able. The title of today's presentation is July 2023 Catastrophic Flooding in Vermont. I'm glad to have Rebecca Duell, meteorologist at the Forecast Office in Burlington, Vermont, with us today. Following Rebecca's presentation, we have Alistair Martinelli, the ITO at the Forecast Office in Salt Lake City, to facilitate the discussion. Just a few reminders. As you heard, this session is being recorded. There is an opportunity for Q&A, as always, after the presentation. We ask until we get to that Q&A that you mute your microphone and turn off your webcam if you're not talking or presenting. If you have signed in, if you have not signed in using your full name, we ask that you please note your name when asking a question in the chat, because we will follow up with you if necessary. And as always, we will field the questions in the chat in the order they are asked. We're always looking for future presenters. Please contact our TowerS team. There is a link in the chat if you would like to be part of the next 100 Satellite Book Club seminars. And the training team can help create training materials that may be unavailable or point you to resources you may be unaware of. Ross Van Til can help with that. I'd like to thank the Office of the Chief Learning Officer, the GOZAR program, the JPSS program, our presenter, facilitator, and again, all of you for being with us, not only today, but through all of these Satellite Book Club seminars that date back to 2020. Without further ado, let me introduce Rebecca, who is a repeat presenter here at the Satellite Book Club and a forecaster, as I mentioned, in Burlington, Vermont. Rebecca has been at the Burlington office for 6 years and was previously at the office in Anchorage, Alaska. She's originally from Louisiana and has a passion for severe weather. After almost a decade forecasting for northern offices, she has developed a passion for winter weather forecasting. So Rebecca, glad to have you. Welcome to the book club today.
Thank you so much, Jordan. Happy to be here. I'll go ahead and get started. Thank you so much, everyone, for joining us, and good afternoon. My name's Rebecca. Like Jordan said, I'm a forecaster at the Weather Service in Burlington, Vermont. And I'll be talking to you today about the catastrophic flooding that occurred in last July, so July of 2023, in the state of Vermont. So a little overview of the storm. What ended up happening, we had 3 to 9 inches of rain that fell within 48 hours over Vermont. And here's a map you can see here of where the heaviest rainfall fell. These purple colors, this is amounts anywhere greater than 5 inches here. So if you are familiar with the state of Vermont, that is right along the spine of the Green Mountains. So we had a lot of really heavy rainfall falling over an area with a lot of topography. So that led to a real flash flood threat and a really dangerous situation that developed quite rapidly during the overnight hours. We had flash flooding throughout the state. We also had multiple main stem rivers hit major or record flood stage as well. And leading up to this event, we had already had a really wet start to July. So this actually occurred, the heaviest rainfall occurred July 10th and 11th, but it really kept going after that. So the first few days of July were already quite wet. So we were dealing with quite saturated soils to begin with in the first place. So going through this presentation, I'm going to be starting out with a satellite overview. Given that this is a satellite talk, we'll be talking about the meteorological setup for what happened. And then after that, we're going to pivot and talk a little more about the DSS, so the decision support services that came out of our forecast office here in Burlington, and how that helped to message the emergency managers to ultimately act in a successful way, essentially having resources deployed throughout the state before the rain even began. So we'll go ahead and advance to the next slide, start talking about some of the meteorological setup. So this is a look at the water vapor satellite. This is channel 9 And this is leading up to the event. We had two jets in the upper levels to point out. There was one jet to our north and west, setting up over Ontario and Quebec in Canada, and we were in the right entrance region of that upper jet. And then there was another jet to our south that eventually moved more towards our southeast eventually, and we were in the left exit region of that jet. So we had that dual jet structure, so we were in that region of upper level difluence, so very favorable looking upstairs. And then if we go a little bit lower in the atmosphere, next slide, looking at the mid levels, we were part of a larger scale omega block. So we had an upper level low that was set up a little further north than this satellite imagery, but it was set up over northern Ontario, and then well to the east of that was a strong blocking upper high that was set up more closer to Greenland, and that was the westward extent of an omega block. So essentially what ended up happening, as we were in between the upper low and the upper high, the system stalled over our forecast area, and it really was stopped by any further eastward progression by that blocking high just to our east. In fact, that blocking high did retrograde a little bit westward as the event panned out as well. We also had a shortwave trough that you can see that rounded the base of the long wave trough, and that shortwave trough, it was strengthened a little bit by the upper level difluence as well, so worked in tandem with the upper level jet structure as well. And also wanted to point out on this satellite imagery, you can see this S shape here, patterned over New England and New York, and that is a baroclinic leaf, which is rather unusual for midsummer to set up. So it really speaks to the strength of the mid and the upper level dynamics, and also the jet structure that was driving the vertical motions for this event. So a lot of interesting features to look at on the water vapor satellite leading up to this. We can go to the next slide. All right, so this is a very crude little analysis here, but we ended up in the lower levels near the surface. We had a low pressure system. It was actually relatively weak. It was nothing exceptionally strong, but it was a low that moved northward into southern New England. There was a cold front extending to the south and west of that low, and a warm front extending to the south and east. And more importantly for our area, there was an inverted trough that set up just to the north of that low pressure system, right along the spine of the Green Mountains. So that inverted trough helped to increase the lift in the lower levels as well. So when you coupled everything together, we had a setup where we ended up having a system stall overhead in a region with a lot of lift, and also, as you can see in the next slide here, a lot of moisture moving into our area as well. So this is the blended total precipitable water product. This is helpful in identifying areas of high moisture that can lead to heavy precipitation and flooding events. And the blended product specifically is the one I chose to use here. It's helpful because it's available both in clear sky and cloudy conditions. It's a little bit less frequent, but you can see really well on this that tropical moisture in those red colors and even into those yellow colors. You can see that tongue of moisture that pulled north into New England. So in fact, there was a southerly low-level jet right overhead into southern New England, and our forecast area, so Vermont, was just on the nose of that southerly low-level jet. So strong influx of Atlantic moisture, maximum moisture convergence overhead with the nose of that jet directly over our forecast area. So everything coming together for a really impressive rainfall event. We can go to the next slide. And this is the Sierra advected layer precipitable water product. This is pretty neat. You can see it looping through it's available at different layers, and it shows moisture at different layers of the atmosphere. So on the top here, you can see the moisture at the surface to 850 millibar layer, and then below that is 700 to 500 millibar layer. It's a polar orbiting satellite system. It's a system of satellites, so there is some data dropouts. Initially, you can see there's a little bit of data missing over New York. That's where there was precipitation. But then the bigger areas were just due to lack of sampling on the temporal timescale. But overall, I want to point you to the area that's circled in the red here, and you can see the influx of Atlantic moisture just moving up from the south there. And if we go to the next slide, we're going to look a little bit higher in the atmosphere as well. So that bottom panel here, that's 500 to 300 millibars. And what's especially impressive is it's not only low level moisture, but it's actually reaching quite high up into the atmosphere as well. So the depth of the moisture moving into our forecast area was very impressive overall, setting us up for really high precipitation efficiency as well. Next slide. And this moisture was sampled by the 18Z Albany sounding. So Albany did a special sounding the day before the rain started. So this was before the rain. And on that sounding, and Albany is our closest upper air site, so this is the best sample we had. They sampled 1.98 inches of precipitable water. So for the northeastern US, that's pretty darn high. So high moisture content air mass. On this sounding, the warm cloud depths was 13.6 thousand feet. So pretty deep warm cloud depth as well. So good warm rain processes, increased precipitation efficiency throughout this event as well. So that definitely played a factor in our precipitation rates as well. So all that coming together, our forecasters had a pretty good idea that this was going to be a pretty dangerous event in terms of a lot of rain falling in a relatively short amount of time in an area that had already had a lot of rain and really couldn't absorb very much more rain. So if we go forward, we're going to pivot now and talk a little bit more about the decision support services that came out of our forecast area. Starting a few days before the event, the actual rainfall fell the morning of the 10th of July. This is the 8th. So we're looking a few days ahead of time. We're going to go in order now through time. Our office had been sending out these emails. This is something pretty typical. Most forecast offices would send out emails to their partners ahead of any sort of bigger events. And this is an example of one of the emails that went out when we were advertising widespread flash flooding that was going to be occurring. It's usually a mix of some images along with some bullet points in text format. So it's kind of a nice mix, so our emergency managers can hopefully find that information easy to understand and then they can act on it. And as we went further in time, and as we got closer to the event, this actually turned into a bigger scale, full PowerPoint presentation with multiple slides. But this is just an example of one of the earlier emails that had gone out. Next slide. So it was a no-brainer at this point. 2 days before the rain started, we issued widespread flash flood warnings for the entire state of Vermont as well. Albany covers the southern 2 counties as well for Vermont. So both of our forecast offices had issued flash flood warnings for the state. Going ahead. And in terms of reaching out to the public, this is an example of one of the social media posts that we did. This is a timeline graphic that we found quite useful, especially when you're trying to message multifaceted events that maybe last a little bit longer time scale. So this is something that one of our forecasters brought from the Boston office. So we've really liked this. The colors are actually based on social science research. So you have the purples that are the greatest time frame or the biggest threat of weather. So it really stands out. But we were able to message in this how an initial flash flood threat would eventually, after the rain stopped, it would pivot and turn into a slower pace, but still very deadly river flooding threat as well. So this was one way that we kind of used to message how the event would play out. And this was one of our posts for social media. Moving forward. So now looking the day before the event, this was July 9th, if we keep going here. So everything was still coming together. The higher resolution models had come in at this point, and we realized we were going to be dealing with 5-6+ inches of rain. So we knew we were dealing with a really dangerous situation. Our forecasters worked with the Weather Prediction Center, and the forecasters at the Weather Prediction Center issued a high risk for excessive rainfall outlook. So the ERO, the excessive rainfall outlook issued by the WPC, this was actually really important. This was the first time that a high risk ERO had been issued for our forecast area. So this is the social media slide that went out and the text. This really helped to indicate to the public just how important or how critical it was that they take this event very seriously. This was going to be a very rare event in terms of the magnitude of the rain. So that was a good way of collaborating with both the national offices in the Weather Prediction Center and also the local offices as well. So some good collaboration occurred there. Continuing on. We did do a survey after the event where we asked some of our partners how our messaging worked for them and whether certain words that we used in our messaging helped them to act in certain ways. And I'm going to include some of their feedback on this presentation because I think it's pretty helpful to go into the mind of the emergency managers and what they were thinking when they received these forecasts and these images from us. We asked them, did being in the high risk ERO make a difference in your decision making and deployment of resources and assets? And interestingly, one of our on-air meteorologists said certainly having the WPC excessive rainfall high risk over the weekend was something very visual and different to show on air. So that's really important in that our broadcast meteorologists, they're obviously our partners and so important in getting the message out. So the fact that we were able to give them something really different to show on air to really catch the public's attention, that was very helpful. And I think a really good use of that high risk ERO. As well as the emergency managers found it very helpful as well. You can see a quote from an emergency manager on the right from Vermont Emergency Management. They said, definitely we use these images to manage assets such as urban search and rescue teams. Going forward. We also decided what verbiage can we use as an office going forward to really hit home just how serious this event was going to be. And we decided as an office to use the terms catastrophic and life-threatening. Obviously, these are not terms that we throw around lightly at the National Weather Service. This is exceptionally rare that we would use these terms, but we did decide in this event that this was a time that we wanted to use these terms, and this was picked up on by the media as well. So the public as a whole, I think in general, were very aware that this event was going to be very different. Moving forward. We asked our partners how the use of the word catastrophic impacted their decision making. And here's some quotes from emergency managers at Vermont Emergency Management. One of them said, yes, it was an exact choice of words. It gave a degree of urgency to planning and aided in the relation of seriousness to executive staff. And perhaps most critically, another emergency manager said, yes, it helped them to mobilize earlier. And ultimately, that earlier mobilization was key in saving lives. So moving forward. This is still July 9th, the day before any rain began, based on NWS communications and forecasts, the governor of Vermont, Phil Scott, issued a state of emergency. And this was before the first raindrops even fell. So a few things happened at that point. The State Emergency Operations Center was opened and staffed 24/7. We were doing virtual briefings every 3 hours at that point to the emergency managers. And most critically, the swiftwater rescue teams were brought in. I think 7 different states sent in swiftwater rescue teams ahead of and during the event. And they were staged around the state before the rain even began. So, moving forward. This is a radar loop. So this is actually over the course of a few days. You can see it's a little hard to see Vermont behind all that rain, but what you can see is just wave after wave after wave of rain. And that's because we had that stalled upper level pattern, that blocking high to our east. We had a ton of Atlantic moisture moving in, and it just ended up being wave after wave setting up. Now, keep in mind, this area has a lot of topography as well, so that certainly played a role. Some areas could handle these amounts of rainfall, but an area that was already saturated soils with a lot of topography, very steep mountains, was very vulnerable to this amount of rain. So, moving forward. So this occurred, actually the heaviest rain occurred during the overnight hours, the morning of July 10th. Our forecast office issued a flash flood emergency. Sure enough, we had many swiftwater rescues. There were in fact over 200 swiftwater rescues performed. In fact, the fact that the heaviest rainfall fell during the overnight hours was especially dangerous. A lot of the swiftwater rescues happened in the dark. People were sleeping. They may have been caught slightly off guard by the rain and the amount of time that it took. It was so fast that this rain fell during the overnight hours. So it was absolutely critical that we had those swiftwater rescue teams in place ahead of time. And I actually combed through quite a few newspaper articles after the event as well. And time again, you can see this quote off to the right from the VT Digger, which is a local paper, but time and time again, people were saying, both the emergency responders and also the public were saying that we knew this storm was going to be bad. So in terms of our messaging, I think we messaged it quite effectively ahead of time. Going forward. All right, so once we had the flash flooding, And the flash flooding threat really came to an end after the rain stopped. So this was a couple days later. We ended up having multiple rivers hit major flood stage. In fact, some of our rivers actually hit record flood stage. You can see this is just a few of our historic crests that we saw. Most of the rivers fell short of the crests that were recorded from the 1927 flooding. That's kind of the benchmark for our area. But since then, a much better dam system has been put in place. So hopefully we never reach those levels that we saw in 1927. But a lot of areas did see flooding on par with what we saw a little over a decade ago in Hurricane Irene as well. So this was definitely one of the top 3 events for our state. Going forward. And here's just some pictures of the flooding, the flash flooding. A lot of those pictures on the top was the flash flooding. Top left was one of the towns that really just got hammered during those 5, 6, 7 inches of overnight rainfall. And then bottom left, that's the capital of Vermont. That's Montpelier. And you can see the gold domed top of that building there. That's the state capital. And the Winooski River usually flows within banks close to there, but you can see the Winooski River was completely overflowed. And that picture in the center on the bottom there, that's the capital of Montpelier, just completely inundated with flooding. And that was due to the river flooding that Montpelier got flooded. And unfortunately, it really took a toll on all the businesses as well as the entire community. It's just one of the many communities that really suffered. Going forward. We did have our forecasters deployed on site. So we deployed to the Emergency Operations Center from July 10th through July 21st. We had 3 to 4 briefings daily, including briefing the governor. And this is one of our forecasters briefing, you can see there. We also had several, that was, I think the Secretary of Transportation came to Vermont, and that's one of our forecasters briefing him as well. You can see. So the next slide. Once the rainfall started to come to an end, we transitioned to remote support. We stayed in a remote support setup from July 22nd all the way through September 1st. We provided the exact same functions, the exact same support. We briefed the governor multiple times a day. What made this event particularly difficult for the area to recover from is that multiple rounds of rain followed this. So unlike Irene, which was back in 2011, where we had a drier period after that, this one, we really didn't have a dry period until fall. So the rain just kept coming, and obviously with the culverts being washed out, the area was exceptionally vulnerable, especially with all the recovery efforts. Everyone was in the field. We had a lot of heat, a lot of humidity, and a lot of extra rain. So there was a lot of work, not only helping with the recovery, but also keeping everyone safe who was in the field working throughout the state as well. So that's something else that our office played a big role in as well. Moving forward. So I'll just close it out here. A look at some of the impacts. Like I said, over 200 swiftwater rescues. We had major river flooding. Dozens of landslides. That was something that we hadn't dealt with as much before, but we had landslides all over the state. In fact, at one point, I-89, which is the main interstate running through our state, was closed because a landslide was over I-89, and that connects Montreal to Boston. So that's a pretty big interstate there. They're still counting up the amount of damages total, but there was over $300 million in damages. Obviously, Vermont is very rural state. It's very agricultural. So the farmers also were hit especially hard. A lot of crop damage with this storm as well. And unfortunately, we did end up having 3 fatalities. One of them was a hiker on the Appalachian Trail, and another one was somebody who was walking along a riverbank and then ended up unfortunately falling into a river, and the currents were just so strong. So that was something else that we were trying to really message after the event. Once the sun came back out, that the threat was still there in the area rivers, and to stay out of area swimming holes and things like that to keep the area safe. So that was something else that we were messaging a lot during and following the event as well. So moving forward, I have some acknowledgements. I want to thank, I think I saw Dan is on this call, but thank you very much, Dan Bikos from Sierra, for providing all of the satellite imagery used in this talk. I'm very grateful. And also a big thank you to our Science and Operations Officer, Pete Banakas, as well as 2 of our lead forecasters, Maureen Hastings and Rodney Chai. They both have done fantastic presentations and write-ups on this event, and I used some of their material in this presentation, so it's really been a team effort. Thank you very much, and with that, I will hand it over to Alistair.
Thanks, Rebecca. That was quite the event and a great presentation. I'd like to encourage everybody to stay on for the upcoming Q&A. And at this point, if you would like to change your camera setting to active cameras, you can do that in the upper middle of the screen, whether you're on the website or the app. Mine says defaults to everyone, but you can click on that down arrow and then select everyone. Emily is going to throw a feedback link in the chat here in a second. If you guys have any feedback about this session, there's a short survey to fill out if anybody would like to take the time to do so. Next week, 1 week from today, Thursday, August 1st at noon Eastern, Devin Sheehack will be meteorologist from the Midland, Texas Forecast Office will be discussing an extreme microburst in Lea County, New Mexico on May 31st, 2023. Also, Pam Sullivan, the director of the Geo Operations Office, Observations Office, will be providing introductory remarks to celebrate the landmark 200th session of the Satellite Book Club. If anybody has any questions about the Tower S team, or that you can contact the Tower S team by hitting up Kashad Brown or Emily Maddox for questions about Satellite Book Club or configuration of satellite products. And at this time, we can start with questions. I got one for you, though, Emily. I mean, we were talking before this all started and stuff, but how rare or common are flooding events of this magnitude in your Vermont, in your area?
So flooding events of this magnitude are quite rare. However, ironically, this last year we had flooding not quite to this magnitude, but it was pretty severe as well on the exact same date. So it was July 10th, 2024. So actually, when I was compiling a lot of this information, I was compiling it right around that time, and it was crazy because we were seeing a similar setup occur again in 2024. So this is actually the third time that a lot of our rivers have gone into major flood stage, or at least some of our rivers have gone into major flood stage in the last year. We also have a lot of snowmelt flooding in Vermont as well. So that's another real challenge during the winter and the spring months as well. So we had some flooding then as well. But yeah, it's becoming more and more common now in our state. But the last time before this that we had flooding of this magnitude was Irene in 2011.
Thanks. So we'll go to the questions from the chat. I have a question from Bill Silberg. He asks, did you get a chance to look at the NewCap sounding prior to the event, and did you check out the satellite flood products after the event?
Yes, good question. We did. I remember we looked at the NewCap soundings during the event. Since we don't have an upper air site, or we are not an upper air site, they can be really helpful in looking at the environment overhead. And it's definitely something that we use in our office for sure. I did not pull up the archived NewCap soundings when looking back at this, but I know, especially like I said, being that we don't have our own sounding, it's something very helpful to look at, especially when you have this air mass with these high amounts of water. You can really see that on those soundings. So, and what was the second part of the question?
Oh, the second part was, did you check out the satellite flood products after the event?
Yes, I think we did. I was not part of the team that went and looked into the flooding. We had multiple teams. I think three at sometimes, three teams who went out and did the surveys. But I do think they used as well the flood products on the satellite as well afterwards. But I can't speak personally on how those were used.
Another question from Scott Lindstrom says, very nice presentation. Did you also look at, or do you also look at the blended TPW percent of normal product, which I assume was 200+% for this event?
Yes, and yes, and hi Scott, it's been a while. But yes, we do. We absolutely do use the percent the percentile as well, and that was close to 200% as well. So that is something that we also look at a lot. That blended total precipitable water product is really useful, especially in identifying these air masses when they come north from the Atlantic into our area. And the percentiles can be very helpful in identifying those as well. So yeah.
Okay, thanks. Another question and comment from, don't know where GYX is in the land of
That's our
Weather Service
partnership piece.
acronyms.
That's great. That's
Okay.
great.
So their question is, how would you, they said great job, and how would you compare the messaging from 2023 and the anniversary storm?
Yeah, that was tricky. We had a lot of people ask with this last event that occurred in 2024, is it going to be as bad as the 2023 flooding? Um, you can imagine when we say flooding now, and people take it really seriously, especially given that we've had three pretty severe flooding events in the course of 1 year. So now Vermont, our emergency managers, as well as our public, they're hyper alert to the flooding, which is good. They're ready to take it seriously, but in some ways we had to message in this next event that it wasn't going to be as serious as the previous flooding. So that was a little bit of a challenge. Was trying to differentiate that, we did not use those terms like catastrophic and life-threatening flooding with this one this year. We knew that it wasn't going to be as bad. It certainly was going to be some problematic flooding, but it wasn't going to be as bad. So we keep those more extreme terms, to those once in a few decades or once in a lifetime events. But yeah, that was part of the challenge, was trying not to over message this event, this one from this year, the anniversary event, but also trying to get people to take it seriously enough because it was going to be a dangerous storm as well.
For sure, it sounds like you hit the nail on the head with both of them. At the moment, we don't have any more comments. If anybody else wants to weigh in or ask Rebecca any questions, we're happy to take them.
Hey, Rebecca, this is John. Great job. I'm John Goff. I'm the senior service hydrologist at Burlington. The one thing I would add, Alistair, in regards to the question regarding the satellite flood products, Bill's question, we also had a tremendous amount of aerial drone imagery immediately following the event from the University of Vermont through the Cairo working group. That was very, very instrumental, very high res drone imagery from the state capitol and through many other areas that they were able to get out, boots on the ground right away, and to help document flood and inundation mapping and some of that rolling into the water model that's been rolling out across the country. So I thought I would just add that real quick. That was another piece of information we had in addition to the satellite flood products, because it was much higher resolution in a sense, because you're only 100 foot off the ground. Thanks.
Yeah, thank you,
Hey,
John. Yeah, John's the one who did a lot of our surveys and organized a lot of that. So he's the one who used a lot of that imagery the most from our office, for sure. He's our hydrologist. So
thanks, John. Anybody else have any comments or would like to weigh in? Please do so now.
Alistair, I think you're on mute.
Oh, sorry. I was going to say, hearing no more questions or seeing no more questions, I guess I will turn it back over to you, Jordan.
Thank you so much, Alistair, and thank you, Rebecca, for that great presentation. Really appreciate the insight, and sounds like overall great service provided by the forecast office in Burlington. So thank you for sharing that with us today. And from here, we're on to the 200th Satellite Book Club. As has been mentioned, we are going to have Devin Chehak, the meteorologist at the forecast office in Midland, Texas, discuss an extreme microburst in New Mexico in May 2023. We're going to have Pam Sullivan, the director of the Geo Observations Office, provide us with some introductory remarks to note the occasion of the book club. So with that, just note that you can always get in touch with the Tower S team, whether you are using Slack or via email with Kashad Bowman and Emily Maddox. let us know any questions you have about satellite, whether it's regarding configuration in AWIPS or just wondering about the current series or the next generation. We heard recently that GOES 19 is now on orbit, so we hope to share additional information about that mission soon as it transitions over to GOES East. We'll wrap it up there for today. I hope everybody's summer is going well, and see you next week. Thanks, everybody. Really appreciate it.